Alright, so this video will be mainly about normal distribution curves and finding the percent under a certain amount. So let's just start. This first question is saying Professor Hallen has 184 students in his college mathematics lecture class, and the scores on the midterm exam were normally distributed. So they had a mean of 72.3 and the standard deviation of 8.9. Then they're asking how many students in the class can be expected to receive a score between 82 and 90. So you have to express your answer to the nearest student. Okay, so first of all, let's draw everything. Let's just write down everything, all the information that we gathered. So we said we have a mean, and this symbol is mu, which means mean. So the mean is 72.3, and the standard deviation we can that's the symbol of it. That's the symbol of it. And then they said the standard deviation of 8.9, and then they want to find how many students score between 80 and 90. So first, let's start with 90. Because look, let's say this is our curve, and they said the mean is had about 72.3, and then this moves by 8.9 because one standard deviation is 8.9, so 72.3 plus 8.9, and that moves us to 80. 1.2, 80, 1.2. And that's how when we add another 8.9, that'll be the second standard deviation. And we can also move backwards, subtract 8.9, subtract another 8.9, subtract another 8.9. That's how the curve usually goes. And you have to remember this equation. That's to find like the percents. When you want to find the percent under a curve, first you have to find z, and then you have to refer to your z-score table, and then you find the percent there. So first you have to memorize the equation. Z is equal to x minus mu over the standard deviation. In this case, we have x, and x will be 90, because that's the one we were working for, 90. And then we will do another equation where we have 82 as x. First we're going to start with 90, so we can put 90 for x, minus mu, and mu is mean, which is 72.3, over standard deviation, which is 8.9. 90 minus 72.3, let's jump into the calculator. 90 minus 72.3 is 17.7. And then that 17.7 over the 8.9. And 17.7 divided by 8.9. Now I encourage you guys to do this with me, like do it along to make sure we're on the same pace. Now 17.7 divided by 8.9 will be 1.98, so we can round that to, we can keep it 1.98. Let's just keep it 1.98, or we can do it 2. It doesn't really matter. Now this is z. We found z. Once we found z, we go to our z-score table. It should look something like this. Here are all the positives, here are all the negatives. So 1.98, and we zoom in. Here's 1.9. Make sure you guys see it. So there we have 1.9. We move all the way to 1.98. Now the 8 is somewhere 1.98. Okay, so it's in this column, second to last. And then where's the 1.9 again? It's right there in that blue. 0.9761. So 0.9761. We multiply that by 100, that will be 97%. So we have 97% already. And we're going to subtract that by the percent that we get when we put 82 as the x. So let's erase everything here. In this case now, x is going to be 82 minus the standard deviation, mu, which is 72.3 over 8.9. Now, 82 minus 72.3 is 9.7 divided by 8.9 divided by 8.9. That'll be 1.089, 1.09. 1.08, or actually it's just 1.09. 1.09. So 1.09, we want to find this at our z-score table. First we have to go to 1.0. There's 1.0. Let me actually, there. Wait a second. I put it all the way on the bottom so we don't get lost. So 1.09. So that's 1.0. 1.09 is 0.8621. So that means that's about 86%. 86%. Now we subtract these two percentages, and that's the area between 90 and 80. If we have like our normal distribution, we found the area under here, which is 97% minus 86%, which is 11%. So the answer to this would be, what was, we said 97 minus 86, and that is equal to 11, and we want it in percent form. So let me bring this, and so to answer how many students in the class can be expected to receive a score between 82 and 90, we expect to answer to the nearest student. 11% of 184 students got that kind of score. So we want to find what's 11% of 184, and we could just simply get 184, multiply that by 0.11, because 11% is 0.11 in decimal form. And that's only 20.24 students, and we can't have 0.24 of a student, so we have to round it to the nearest student. And 20.24 most likely, or would, round to just 20. So the answer for this problem would be just 20 students would get a score between 90 and 82. And let's check our answer, and where is it? There are 21 students, because I wasn't too picky about it. I wasn't like very specific in the percent, just rounded. But in a multiple choice question, or on any test, maybe it's best to go to be really picky about it. But it really doesn't matter. I don't think they're going to be too strict on you. And that's basically how you do it. That's the basic principle.